Let's look at calculating an annuity, but we're going to do it with compound interest. So we'll talk about that. We'll read our question. So Dave makes $2,500 deposits in his RRSP on his 20th, 25th, 30th, 35th, and 40th birthdays. The RSP gets 7% per annum compounded annually. Okay, that's simple enough. We don't have to worry too much about compound periods. Determine the value at the age of 65. Okay, so this is an annuity because he's putting in a payment every couple years, right? Normally, if it's just an interest account, you put in a one-time payment and you let it go. The problem is, or the problem with this formula that I usually give you, is this formula needs what they would call the compound period and the payment period. They need to be equal in order to use this concept. And if we do a little timeline of this, we're going to see that this is actually definitely not equal. So we're going to probably have to use compound formulas to this. So let's draw our timeline. On his 20th birthday.
Would this formula be better for the question?
You will still have to set it up that way. Yeah. On his 20th birthday, what did they say? $2,500? Yeah. Okay. So he makes it a positive $2,500. And it gets. Actually, let's do that before I calculate the interest rate. Then again, on his 25th, so that's a 5-year difference, right? Mm-hmm. Same event happens. Okay. And then again on his 30th, 35th, and 40th, is that right? Yeah. Mm-hmm. Same event is happening in all these timelines. Great. And then, 55. At 65, money comes out. This is when he wants to know what he's got, right? Already right there, we can tell that, well, he didn't make any payments on the 45th, the 50th, and the 55th birthday. And an annuity, like we said, it needs to be, it needs to be having the same pattern all the way through. And it needs to have the payment periods and the compounding periods to be the same. So he's definitely going to get interest on those days, but he's not making any payments on those 5 years. And let alone those 5 years, he's actually not making any payments on 21, 22, 23, or 24, and he gains interest every year. So what's actually happening, like we talked about, is in between each of these. We'll move this down a little. Whoops. Ooh. Maybe I'll just write on the side. In between each of these, there's a 5-year of just interest happening. Mm-hmm. Okay? So because that's happening, we're going to have to add up a couple of the actual compound interest formulas instead. So because it's a compound interest formula, we have to think of every one of his 5 payments as a different event. Okay, so 2,500, 2,500, and then 2,500. Each of these is a question within itself. And that's where this future amount equals the present value times 1 plus I to the power of n. That's where this comes in. So we're going to do this 5 different times. So this would be the first time we do it. And the first time we do it, we're going to have to calculate. So it becomes the present value, which is our 2,500, times the 1 plus, what did we say the interest rate was? 7%. And because it's compounded annually, so that's each year.
It's not going to change.
Yeah. And now here's the end. The end is the tough one. It is definitely every year. When is he taking this money out?
After 65, so...
So how many years in between is that? Take a look.
I don't even know. 65. Let's subtract. It's 30. What? Like 35 or something.
45 it should be. Yeah. 65.
40.
You use 6. Oh, you did 25. That's at 20.
Oh.
Yeah. Okay. So at 20, which is good because that's the next question.
Okay.
That's good. So the very first one, we set it up and we're going to get a value. But before we get all our values, let's set up each one. Next one, here's our payment period. So I'm going to put the P over here. And then above all of this, this is our 1 plus I to the power of n. That's what all of those are. That's what all of our P's are. The P is the same. At 25 to 65, like you said, is 40. So then it's doing the same thing over and over again. This one's 35. But you see that gap?
Yeah,
because there's that gap, we can't use... Whoops. We can't use this formula because the payments in the compound periods are not the same. So we have to set it up and do it separately every time.
Subtract them.
Yeah. So then.
Or add them, I mean. Sorry.
Yeah, that's right. Okay, so now we gotta go about calculating each of these events, and altogether that will tell us what we would earn in the very, very end here. So luckily in this little calculator, I can kind of keep my old values. So I'm going to type it in here, 2,500 times bracket 1.07 to the power of 45. Okay. So let's see, 52506. 2506. I'm going to leave the cents out of this. Okay. Now I get to keep that same formula and I can manipulate it. There we go. At 40, you get 37436. 436. Okay. Formula again at 35. 26691. 30 years, 1930. 30, and then again, very last one at 25 years.
That's cool. I didn't know even know that feature.
13368. 368. Okay, so I kind of screwed us out of all of our pennies, so we might be a couple dollars short in the end, but for time's sake, yeah. So let's add these all together. And I don't know if you've done that, but I think on this calculator I can just steal the values. Let's see. Yes, I can. Plus. Oh, how nice! I like this calculator. Plus.
Makes it easy.
Yeah, and now I'm actually not messing up any of our cents. In
Perfect.
fact, I'm getting all of them, even like percentages of cents we're getting in here. Okay, so according to this, we'll get
That's a lot of money.
149,232. So 149,000. I already forgot. 232 and 94 cents. 232 and 94 cents at the end of all of this, and that's a pretty good amount considering he puts in 5,000. 10,000. He puts in $12,500. He ends up with $150,000. That's a significant amount of money to earn over that time.
What was the number that we came up with?
We came